Alright, so this is video number 2 for harder derivative problems. These problems are problems that you would typically have on a test that is supposed to be um, a final, for example, or something that's just supposed to be a little bit more challenging, maybe towards the end of the test. So let's see here. So this is going to be y is equal to 2 raised to the x squared plus 2x plus 1 multiplied by cosine squared x. So this looks like a mess. For some people, this is an easy problem. And I think for everyone, it should be an easy problem if you just break it down a little bit. And it's easy to make mistakes, though, so make sure that you try to avoid making any mistakes. So we want to find dy by dx. I'm just going to switch colors here. So dy by dx. Now, one thing that I wanted to see here is I want to use a product rule. So I need to differentiate this, multiply it by this, then I need to differentiate this, multiply it by this. So you see it's like a x. So you go from here to here, right? It's like an x. So anyway, that's just a product rule. And the first term we want to differentiate is this. Now this is an interesting term because it's in the form 2 raised to something power. And when we want to differentiate something like this, you might not remember the rule. You might not remember the rule because I forget this rule all the time. But one way I remember this rule, I've covered it in other videos, is by looking at the derivative of e to the x. Because e, remember, is not a variable. E is a value. E is like pi, right? It's a constant. It's not going to change. And it's like something, it's some number, 2 point something. I don't remember. But anyway, we don't have to remember. This is just equal to just what? E to the x. Now, if your teachers taught it like this, or if you look it up, this is going to be e to the x times the natural log of e. That's very important. Basically, the derivative d by dx of a raised to the x power is just equal to a to the x times the natural log of a. And if a is equal to e, then that's just e to the x. But here, this is equal to 1. So this is just e to the x, right? So we have nothing to worry about. But if we have something that's not e, when a is not equal to e, not 0, e, then we would have d by dx of, well, we would essentially have natural log of a not equal to 1, right? So that's something that we can think about, right? So anyway, we can use this property. We can use this to solve this problem. So the thing with this problem is going to be a little bit more challenging because after that we have to use the chain rule. We're differentiating this, right? We're finding d by dx, as I wrote before, 2 raised to something power. How do we do this? Well, 2 raised to that same power, x squared plus 2x plus 1, multiplied by the natural log of 2. That's pretty much it. But we have to, since we have this function here, we have this portion, we have to differentiate that as well. It's just going to be 2x plus 2. And that's good enough. Okay. This is the derivative of the first term. So that's good. After that, we have to now multiply this by cosine squared x. And then we have to add this by the derivative of cosine squared. What is that going to be? Well, that's just going to be 2 times cosine x times negative sine x. And then you multiply this by 2 raised to the x squared plus 2x plus 1. This is a long expression, but we'll see how we can write this now. So let me write this here, dy by dx. Now, you, of course, could have differentiated this thing first and then multiplied it by this and then differentiated this, multiplied it by that. But I just wanted to get rid of the harder one, do that one first. So that's okay. Anyway, this is just going to be what? This is going to be so 2 raised to the x squared plus 2x plus 1 times the natural log of 2 times 2x plus 2 times cosine squared x plus, so actually we have a minus. Let me make that minus because we have a minus there. So positive, negative, negative. 2 cosine x times sine x times 2 raised to the x squared plus 2x plus 1. And that is your final answer. It's a very messy answer. Very messy answer. But again, these are not easy problems, so they will have messy answers. This is your answer right here. That's it. I hope you found this video helpful.